Are you guys doing okay? You can hear me? No problem?
Yes, sir. I hear you.
Alrighty. Alright, the chat. So today we're going to finish chapter 10 if we can. Uh, so layer 2 security threat. This is basically I think this is where we stopped last time, I believe. Don't know if we covered that or not, but um, this is the most vulnerable layer of the OSI model is layer 2, like we talked about. So because you have a lot of vulnerability in there in this layer. One of them is MAC address MAC table attacks, which is basically you get, for example, a hacker or a threat actor, okay, and they send massive amount of MAC addresses. So what caused, because the switch has a limited amount of memory in there, so what they do, they flood the MAC address table with a lot of false MAC addresses, and that will cause the switch to go crazy. And once the flooded with false MAC addresses, so a user wants to access a server or whatever you want to access, and he cannot access it. And this is what caused denial of service. So one of the software they run, they call it MacOff, which is MACOF. It's a Linux base. So it's if you have Kali Linux, little small device you can do, it has this kind of software on it. They sell you a kit for what do you call ethical hacking, and that's what they use. They use that MacOff and they inject uh, massive false MAC addresses to the switch, and it causes the switch to go poop. So now, to prevent this from happening, what you need to do, you need to enable basically, you need to do not Mac, you need to do a port security. So you can specify specific port, how many MAC address that particular port will learn. And if you exceed that number, the port's going to go down, they shut down. And also same thing with the VLAN attacks, include VLAN hopping and VLAN double tagging attacks. This also includes attack between devices on a common VLAN. So that's why you need to take care of a layer 2 because there's a lot of vulnerability. And the other one has the DHCP attacks, which is basically somebody will bring a false uh, a DHCP server or illegit DHCP server, start giving um, addresses to clients, okay, and he point all the traffics to his router instead going to the real router, and that's what they spoof all the information, and they can basically see what's going on. He can view the packets, and that cause some kind of um, basically he can see any packets going in there, and he can read all the information. Actually, that's basically what's going to happen. And the way they do this, let's see if we can have. Let's see. I think I gave you an example last time. Let's see. Yeah, actually, we can do it this way. Let's see. I don't need that one. Let's see, where is this one here? So let's say we have a switch. That's the switch right here. And you have a bunch of machines. Okay. And you have a router, which is this is your gateway. Because we know that, right? And this is will be connected to the switch somehow, directly or indirect. Maybe you have like 2 5 switches, whatever, but that's not the point. Then this one is connected to this, and this guy here. And you're supposed to have a DHCP server somewhere in the network, and provided IP addresses to all these machines. So hacker comes in and they say, okay, let's say he will have access to this port right here, and he plug his little device. Let's say like this, his router right here. He takes that links out, and he plug his own router. He plugs it right here. Well, he plug it to the internet. You see that internet right here? He plugs this one to the internet. Then he plugs in this PC. Oh, sorry. This one here to his device over here. So now he will launch. First, he will launch some kind of attack called DHCP starvation. That's the first attack. The DHCP starvation basically it exhausts all the IP addresses on this particular server. So when the machines in here wants an IP address, they're gonna get it from this guy here, this router. So and still, even though let's say this one is say it's 172.16.1.0 subnet /24. And this guy here is going to be, by default, is going to be 192.168. Ah, dot 168.0.0/24. So what's going to happen is after they launch the DHCP starvation, this machine is going to have an IP address from this router. So let's see what kind of IP address they're going to get. So if you go to DHCP server, you're going to have 192.168 something. Okay. Uh-oh. Why is not doing it?
You didn't set up the DHCP server on the server.
No, this is the problem. Oh. Let's see. GUI. Okay, so this is a DHCP. Well, it's getting from the internet. So let's see. Oh, sorry. My fault. Yeah, they're supposed to do so this is gonna get, let's see. It's supposed to get an IP address from, let's see, internet. Let's see. But this is not on the same subnet. This guy will get, let's see, this guy is going to get an IP address because it's connected to the LAN port. Yeah. So let's see, those they're not because it's not connected to the LAN port. Um, yeah, so what we're going to do instead, we need to connect it to the LAN, which is this way, connected this way. Okay. So now, fast forward. Now those guys gonna get the address from the router, from the small router. Yeah, see that from the hacker's router. So, and that's how it's happening. Now, the question is, can we prevent this is from happening? And the answer is yes. How are you going to do that? We need to implement something called DHCP snooping, which is basically you come to this switch here or a multiple of switches, and you can say, okay, this is the only port we're going to allow for DHCP traffic. So if the DHCP traffic is coming from this port, then we're going to block it. You follow? And that's how you do it. Let's see. Yeah, that's how to prevent the DHCP attacks. Basically, you have DHCP spoofing attacks, and also we have include ARP spoofing, ARP poisoning attacks. There's another configuration to uh, because what happened is when you send ARP, why you send ARP? You send ARP basically you have the IP address of a host, but you want to communicate with that host, you need a MAC address. So what you do, you're gonna pretend you are that particular host, and you give the requester your MAC address instead of the real MAC address. And that's how you spoof actually the MAC address of the destination. And to provide to do this one to mitigate this one here, you have to enable something called IP ARP inspection. Okay, so that's how you prevent that from happening. I don't think in this class you can do all the stuff, but we'll see. Um, include MAC address, IP address, spoofing attacks. You can do that. So all these attacks you can prevent them by implementing port security, by implementing IP ARP inspector, and you can use what else? Uh, Port security limited the amount of network address that specific port can learn. Okay, so for example, you can say, where's that? You can say, okay, any ports right here, you can select them, only can learn, let's say, 2 MAC addresses or 5 MAC addresses. So if somebody here has a Kelly Linux device and they use the MAC off, he send a massive amount of MAC addresses to flood the MAC address table over here. They say, okay, this guy is learning a lot of MAC addresses. So whenever it exceeds whatever you set up, like 5 or 6 or 7, whatever, it's gonna shut down that port. Once they shut down that port, it prevent the attack. So I think in Cisco 3, you have a lab to do all that stuff. Um, Question at this point. And this is really part of the When you specialize in cybersecurity, you take a class about all that stuff. We used to have CCNA security. I don't know. We're supposed to teach it. Then everybody we implement cybersecurity. Then they change it. So I don't know. We might put it back. So, but it's a good class. It tells you how to protect your environment, your network. And like I said, most of the vulnerability in layer two. Why? Because in the upper layers we have a lot of different tools that we can protect, like firewalls, VPN, encryption, all that stuff. The vulnerability is in layer two. Let's see. Yep, port security. So that's a switch attack mitigation techniques. That's what we talked about. So you put port security prevent many types of attack, including MAC address flooding attacks and DHCP starvation. So because you're gonna say you're gonna trust only one port. See that? Like we're gonna trust only this port to forward DHCP traffic. The rest of the port is gonna be untrusted automatically. And by the way, you can set up the trusted port and all this per VLAN. Okay, per VLAN if you want. Because some people they put like for example DHCP for each VLAN or whatever. So you can do it per VLAN base. So we're gonna trust this port, and once you do the port security and trust one port, all the rest of the ports are gonna be untrusted port. And like we talked about earlier, you can do DHCP snooping. I don't know why they came up with this name, snooping, to prevent spoofing. And that's what I say, prevent DHCP starvation and DHCP spoofing attacks. So how you do that? You go to the switch, I think, and you configure IPDHCP snooping, and you create and you allow you configure the port that will be trusted to forward DHCP traffic. Okay, and also to prevent ARP spoofing. ARP basically what you fool the system. You fool the system that you give them your MAC address instead the real address. So when somebody like in an environment, you send the broadcast. You say, I want to talk to this guy. You see, and everybody will receive the broadcast. Let's see. Pin. Let's see, red. So yeah, this is your switch, and you are here. I hate this. Pin. So you are here, and that's your switch. I say this is your machine right here. And you want to talk to somebody, you say this is your network, you have multiple places. And you have to talk to somebody, maybe the router. I don't know. Okay. So you don't know the MAC address of your routers. What's going to happen? You send a broadcast. And maybe the hackers will receive that broadcast right here. And he's going to reply with the false MAC address. Boom. Then you start communicating with him directly. And whatever you send to the internet, you still can go to the internet, but you go through him and he can sniff and see everything you're doing. So to prevent from happening, you need to enable on that particular port. What do you call? You need to enable uh, um, IP-ARP inspection with trust. Okay, so and that's how you prevent it. Now, what else they say? I think we talked about this one. Where's my eraser? So, like they say here, you can do dynamic ARP inspection to prevent this one here. IP source guard, IPSG, prevent MAC and IP address spoofing attack. So, to prevent any attacks on layer 2, beside all these tools, you need to use the proper protocols. Like, for example, use SSH instead of FTP. You have to use SSP, secure copy protocol, instead of just clear text. You have to, if you're doing some kind of transactions online, you're gonna use SSL or transport layer security on it, so you can do that too. And also you can use ACL. ACL is like an access list to filter unwanted access. So how that is happening? So let's see. Uh, well, suppose I have, let's see, how I want to do that. Yeah, you can put another router, for example, here. I don't have serial interface. Let's see. What's serial interface here? So we can shut it down and put serial interface here. And also you can put serial interface on this router. Boo, 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 boo. And connect those together. Uh, and sometimes you might have different LANs right here. Shift control G, 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 G2, G2. That doesn't matter. So you have different LANs here with different source address. So what you say is you can say, I want to write access list to block any traffic coming from a specific host or a specific network. You see, let's say this is Zach's over here, and this is my FTP server here, or whatever. So Zach is a bad boy. He's been has history of attacking people. So I know his source IP address. So what I need to do, I need to put access list to what, block this particular host to access the whole network or a specific host on the network or a specific application. So you can filter in different ways. It depends on what kind of access list you want to do. And that's that's how you use the access list. Or then you can say, okay, I want to allow only this particular network to access um, my website or my FTP server. Okay, so you can permit or deny. Basically, what you're trying to do, you filter your traffic. You filter who you want in your network, and that's what they're talking about. Uh, yep. And that's what they say. Use ACL to filter unwanted access. Okay. MAC address table attacks. This is what we talked about. Switch operation review, because the switch basically has limited amount of memory, and what the hacker does is flooded with uh, with different MAC addresses. And I have a picture here how it's happening. So you have this bad boy over here sitting over here, and he launching attacks to the to this switch. So the threat actor run like the software I was telling you about earlier, the Mac which is like a Linux base. You see, I mean, if it doesn't have access to that switch, you'll be okay. But like if you go to the 601G and somebody has a little device like the Kelly Linux device, which has a RJ45 ports, and you can launch an attack on it too. So, so to prevent this from happening, what we need to do, we need to take care of these ports. For example, any port, we need to disable all auto trunking. What do you mean by auto trunking? Because if he configure this um, port as a trunk, automatically this will become trunk. And if this is carries all traffic for VLANs, okay, he's gonna sniff all the traffic. And also he can launch this software here to what? To flood all the switch with false MAC addresses. And this is what causes denial of service. And that's what they're saying here. When this occurs, the switch treats the frame as unknown unicast and begins to flood all incoming traffic out all ports on the same VLAN without referencing the MAC table. This condition now allows a threat actor to capture all of the frames sent from one host to another on the local LAN or local VLAN. So beside this one, also you can run what we call the Wireshark. The Wireshark, basically, the hacker looks for the payload. Okay, he has a source MAC address, has a source IP address, has the data, the username, the password, especially if you use a clear text application, you can see all that stuff. Um, Now, and that's what they're talking about. This is the massive MAC address. What makes tools such as MacOff so dangerous is that the attacker can generate a MAC table overflow attack very quickly. I mean, in within like seconds. And they're talking about, for instance, a Catalyst 6500. That's a high-end switch. Can store 132,000 MAC addresses in its MAC address table. A tool such as MacOff can flood a switch with 8,000 bogus frames per second. So you imagine if per second, 8,000. So imagine if you can run that for a minute. So that's 60 times 8,000. So that's what? What's 60 times 48, 8,000? That's almost like what? 380.
480,000.
Yeah, that's a lot. In like a minute. I'm not talking about 10 minutes or whatever. So, and especially if you have the Catlec 6500 and this high-end switch, usually it's in the distribution layer. Because what happened is on the network design, this one will be in the distribution layer. Basically, it's going to be look like this. Uh, in tools, pencil. How about pencil? Pencil. Yeah, this is better. Okay, so this is how it goes. This is your core right here. It's your core layer, which is you have the high-end routers. Yeah, looks like a sloppy router, huh? Anyway, so you have the distribution layer switch right here. Usually have like redundancy on them. see, like there. I don't know, something like that. And this is your access layer. This is basically the access layer. You have switches like the 2900, 2960 switches. And you connect all your devices to this kind of switches. You might have more than one switch. And usually this is your core, your distribution layer here, which has the 6500 switches. And this is basically where you have all your policies and VLANs in here. So if he runs this software in here and he coop this one, bring it down, or he can spoof all the traffic. I mean, it brings your whole network down. So that's dangerous. So to prevent this from happening, you have to do your job as a system administrator or network administrator. As a network administrator or IT manager, or whatever you want to call yourself, you need to protect your ports because you need to know who's in your network. This is very, very important. And the way you prevent this from happening by implementing what? Port security. Port security, port security. Um, LAN attacks, I think we to talk about this one here or no? Okay, so this is a video in your book. It's good to watch it in your online, how it's happening. So usually VLAN hopping attacks, this is, look, you see 82.1Q, this is the unauthorized trunk. And then trunk means what? What's the main function of a trunk? It carries traffic for all VLANs, okay? So the 821Q is the dynamic trunking protocol, DTP, okay? So how you want, it is very simple to protect this one here. All what you need to do, go on the switch that act as a trunk and don't set it to auto. If you want to make this a trunk, make it trunk. Don't set anything at auto. And if you have, for example, a port is not in use, shut it down. Because what's happening here, if this one an auto, if this configured as a trunk, and this is auto trunk, it makes this one as a trunk. And we know trunks use all VLANs, carries traffic for all the VLANs. So, so that's what you need to prevent that from happening. So how VLAN double tagging attacks, and this is how you do it. The threat actors is a specific situation could embed a hidden 802.1Q inside the frame that already has 802 a Q tag. This tag allow the frame to go to a VLAN that's original, um, has the 8021 tag did not specify. Why is not specified? Because we know the trunk, because when we communicate between VLAN, each VLAN has a tag. Like this is the frame. For example, we know the frame is belonging to VLAN 10, VLAN 20, VLAN 30. It has a little, we add something to the frame. It's like a frame ID or they call tagging, okay, to know the frame to which VLAN it belongs to. Now, once you get to the port basically carry all VLANs. So that's how they launch the attack to make themselves or to as a trunk. So once they plug to the switch, the port on the other end of the switch will become a trunk. And when it comes to a trunk, then it's gonna carry all the traffics. So that's basically how they launch their attacks. How you prevent this one? Okay, this is how I tell you how to do it. And that's what we're talking about. Disable trunking on all access ports. Because you know to make a port as a trunk, you say switch port mode access. Then you say switch port mode trunk. If it's especially on the higher end switches, you have to turn the protocol, the DDP, and they have some. One of the features has auto, so you need to disable that. Disable auto trunking on the trunk links so that trunks must be manually enabled. So if it's an auto and somebody else on the other side is a trunk, they make that auto a trunk. So to take care of that, you need to say, you need to do it manually. And that's what I say, disable auto trunking. Another thing, be sure that native VLAN is only used for trunk links. What's a native VLAN? By default is VLAN 1. So that's the first thing you need to do is to change it. Don't keep it as a VLAN. And some people would say, okay, well, how about the rest of the ports that not in use? What are you supposed to do with them? You create a black hole VLAN. You know what I'm saying? It's like it's not going anywhere. That's so if the hacker connects to it, okay, it's not no harm. It's a black hole VLAN. Um, DHCP messages, because there's always a conversation between the client and server where it's like four messages going. The client is going to send it to Discover. That's a DORA. You remember the DORA? A Discover, offer, request, and acknowledgement. Acknowledgement. So basically, you would know what kind of traffic is going on that port because each port, especially when you go to DHCP, they have a port 67, 68. So the attackers, what they're going to do, they send a starvation attack. And the goal for this one here to what? To take all the IP addresses, all available IP addresses are not pooled. And that's what they do. The goal of this attack is to create a denial of servers connecting client DSP starvation attack require an attack tool such as Gobbler, which has the ability to look at the entire scope of leasable addresses and tries to lease them all. Whoa. Specifically, it creates DSP discovery messages with bogus MAC addresses. See, I want an IP address. I want an IP address. I think that's bogus. So what's happening is because your DSP server has a scope. Scope means what? It's like a pool of IP addresses. And you know the client leased these addresses. So when this guy sent Gobbler attack, whatever that software, it'll starve, basically, it leases all the IP addresses from that scope. So if you have a user wants to communicate with server or something like that, well, I need an IP address. So at this time, the attacker, what he does, he will have a vague or illegit DHCP server. So the client is going to get an IP address from the illegit DHCP server. So he's going to get it from the attacker, actually. And basically, once you get an IP address from the attackers will control the whole conversation then. This occurs, like for example, DSP spoofing attack. This occurs when a rogue DSP server is connected to the network and provide false IP configuration parameters to legitimate clients. A rogue server can provide a variety of misleading information, including the following: wrong default gateway, So you're going to go through him. So the rogue server provides invalid gateway or the IP address of its host to create a man-in-the-middle attack. This may go entirely undetected as the intruder intercepts the data flow. And the reason why nobody catch him, because look at this. Still the client goes to the internet, but they go to the internet through him. See? They still go through him. And he's in the middle. He can sniff any packets. Wrong DNS server, the rogue provide incorrect DNS server address pointing to the user, to a nefarious website, the wrong IP address, all that stuff to cause denial of service. So the question is how to prevent that from happening. I think they have a video tell you about this one here. And watch that video. Same thing with the ARP. So what you do is you port security, DSP snooping to prevent all that stuff from happening. And the same thing with IPv6. Question. Let me drink some water. I guess I talked too much. What do you think? So
What would be getting into?
I'm sorry.
I said we'll be getting into like to basically trying to figure out what the cause of the security breach is.
Yeah, I mean, if you do lab, yes. And the reason why,
Okay.
if you, for example, have the right tools, especially if you have Wireshark, you can tell who's the source MAC address, who's the destination MAC address, what's the IP address, because you can see the whole frame. You can see the whole frame, the whole packet, everything. That's why you need to be familiar with what do you call it? With Wireshark. It's a good tools because without Wireshark, you don't know. How do I know, for example, that particular host or that particular network is a threat?
Gotcha.
One time, we have a threat from somewhere like in Latin America. I don't know. We get a threat, so we get the IP address. So once we know the IP address, we did some investigation. We know that particular IP address belonged to that particular country. So basically, we have to turn it off. Then do the access list to block that particular network. As we use ACL, but I mean, usually people doing network management, you're supposed to have somebody monitoring the whole traffic. So you have a big monitor seeing all this conversation, where it's going, where it's coming from, what's happening, uh, before it's spread out. And that's why you need to monitor your network. Because if you set up your network and you forget about it, I'm talking about like enterprise environment, because you cannot afford to uh, to have an attack, especially if you are in business. What happened? It's true, maybe after a day or two you fix the problem, but guess what? You lost your reputation. Oh, such a company has an attack. Okay, if I am a customer of that particular company, I'm gonna count till 10 till to be their customer, you know. So to gain your reputation back, it's very hard. That's why people invest millions of dollars on network security, because because a lot of hackers they make a lot of money. If you read reports about the cybersecurity, how much money they making, I mean that's what how they make living. Those hackers, especially ransomware and all that stuff. And some people they do it for fun. Okay, just they have nothing to do, just go and attack. But this is like, I mean, don't think about it because this is like a federal offense. So they put you in jail forever. So, but that's why in the ethical hacking class, so you can learn how the tools that you can launch it like the Mac. I think you have to sign an agreement not to we call it like ethical hacking. Ethical hacking basically you learn how to hack to what? To prevent hacking. So if you're in charge of network security, you have to take those kind of classes. You have to have a lab um, to test things out. Okay, not the purpose if to launch attack on somebody else. So now in the next semester, we need to learn how to secure your land. Basically, we need to do all that DHP spoofing and all that stuff. Where's my? I guess pretty much this is it. One thing to talk about the STP attack, the spanning tree protocol attack. Network attackers can manipulate the spanning tree protocol to conduct an attack by spoofing the root bridge. Root bridge basically is a switch that act as a reference point. Okay, and changing the topology of a network, attackers can then capture all traffic from the immediate switch domain. And to conduct an STP manipulation attack, the attacking host broadcasts STP bridge protocol data unit. So what happened is he can make a false root bridge because we know the root bridge basically is the bridge that all the other uh, root ports are going to be connected to them. So the other switches they're going to have direct connection to them. So what happens if you falsify the root bridge and you make yourself as a root bridge? So you're going to receive all the bridge protocol data units. So you can say, okay, I'm the root bridge. So send all your information. So every single switch in that network, it's supposed to have three status on the port. Either the port is going to be designated port, or it's going to be a root port. Root port means directly connected to the root bridge. So that switch will be connected to the hacker, and he can sniff all the information from there. And also, you have the CDP discovery protocol, and this is like usually it happen um, by default. Like this one is a feature in layer 2 in Cisco switches. We have something called Cisco Discovery Protocol. And if you run that protocol, it's going to tell you what device is connected to you. So let's see. If I go to this particular, well, the problem is I don't have. Well, let's do this. Uh, yeah. Let's see. Let's configure those two ports right here. Let's say no, enable config T, gigabit interface, interface gigabit 0/0. And I want to give it an IP address to bring it up. So this is 192.168.10.1, for example, 255.255.0, no shutdown to bring it up. Okay, so this interface is up. And I'm going to go to the interface S0/0/0. And I'm going to put IP address. Let's say 2.2.2.2. Sorry. 2.1. 255.255.255.252. Let's say no shutdown. Okay. And then I need to go to this right here, to this interface. Uh, no. Enable config T interface S0/0/0. This has a clock rate. So put clock rate on this guy here, 64,000. And it's a IP address 2.2.2.2, 255, 255, 255.252, no shutdown. Okay. So now what I can do, I can go to this device and I can issue, enable, actually exit or end actually. I can put show CDP. Okay. Global CDP information, send in CDP packs every 60 seconds, send in a hold, time, value, blood. Okay, how about show CDP neighbor? Show CDP question mark neighbor. Okay, so that's my neighbors. Those are my neighbor devices. It tells you what port's connected to what. Now I'm on the router. So it tells me I'm connected to a switch, and it tells you the platform of that switch and which port connected to. Same thing, I'm connected to a router through this port and the model number of that port. You follow? So hackers, what they're gonna do, they gather all this information. Okay, they go and see, okay, what iOS, for example, this particular port, this particular model has, and they study what kind of weaknesses this particular iOS has. You follow? And this is how they launch their attacks. They gather information first. They study the weak points in that particular model or iOS, and they have all the rest of the information. They have the what port is connected and the iOS and the platform of the switch and so on. And it doesn't have to be Cisco switch; it could be any switch. But um, but Cisco, they have this particular protocol. People, for example, use it for troubleshooting purposes. But after you troubleshoot it, you need to disable CDP, so to prevent future attack. And that's what they're talking about here. So that's what you need to do. You have to say no CDP run. That's all what you need to do. You enable it and you need to disable it. Now on non-Cisco devices, they have similar protocol called Link Layer Discovery Protocol, LLDP. And it does the same thing as CDP. So at this point, you need to also disable that link discovery protocol. Does that make sense? It has to make sense, right?
So CDP is Cisco, So, like in a network where you're doing um, LDAP and all that, you would use the LLDP.
Uh, Cisco support both of them. So you have
Okay.
LDP and also support CDP. But if you have a
Okay.
non-Cisco switch, if you have a non-Cisco device, only they use LDDP. CDP only for Cisco. Yeah.
Okay. Sounds good.
Um, any other question? Let's see. This is a chapter 10. How many chapters we have for the test? By the way, for the people who joined late, we don't have classes tomorrow, okay? So enjoy your 4th of July tomorrow. Have some barbecue, whatever you want to do. Go to the beach, go to swimming pool, whatever you want to do. So take the day off and enjoy your day tomorrow.